So Robert, can you share your screen right now? Okay.
Hi, can you hear me?
Yes, perfect.
Perfect. So, welcome everyone. Good afternoon. Today I'm going to talk about Oracle Cloud Infrastructure, and we are looking at the network part of the cloud infrastructure. I hope you're all ready, or shall we wait another 2 minutes for bio breaks, and or shall we start right away? Just go ahead and start?
Yeah, you can start right now.
Okay, here we go. So again, hello everyone. My name is Robert Marz. I'm an independent consultant, so freelance from Frankfurt in Germany. By the way, can you see my video?
Yes.
Okay, perfect. Frankfurt is the city right behind me. And as freelance architect, as freelance consultant, I'm usually acting in the role as a senior technical architect with a very database-centric view of the world. So all those Java architects out there are my personal friends. I'm an active member of DBAs, which is the German Oracle user group. And here I'm responsible for the cloud topics inside the database community. And I'm tweeting from time to time, and this is my Twitter handle below here. This is my Twitter handle, and this is my website. And if you have any questions about anything I'm talking today, just drop me an email at robert@datab.org, and I will do my very best to answer it. I am an Oracle ACE, and the Oracle ACE program isn't a closed club, so you can become one too if you wish, or probably you know someone who deserves to be an ACE, so please download the slides after the presentation and click on one of these links at the bottom, and you can just see if you can become an ACE or someone else you know. Okay. So what are we going to do today? Why networking for DBAs at all? Well, if you start your brand new cloud account, it is a little bit like you start a brand new virtual empty data center. So you have, with every cloud account you open, you have a new data center attached to your on-premises environment, and it is an empty data center when you start. And before you can bring in all these computers, in the cloud, it will be virtual machines mostly. You have to do basic setups and wirings, and these are the network setup. And this is very important, and this is the reason we are going to talk about that today. The next question as a DBA that I asked myself is, do I have to do this all by myself? No, definitely not. Sorry. No, definitely not. Ask someone who knows this stuff by heart, and there's probably some guy in your organization that is in charge for these topics. Please don't forget to ask those guys. But do I really need to know this stuff? Nope, you don't need to, but the Oracle Cloud Infrastructure is network driven, and that means everything depends on the network. This is, by the way, true for every cloud provider or every infrastructure as a service cloud provider. And on the other hand, it's the topic of the session, so knowledge never hurts. Let's dig into it and see what networking is all about. So if I know the stuff after the session, what is it good for? Well, you can help yourself. Much more than on premises, you can configure stuff in the cloud by yourself, mainly because after Open to Freshly account, the rights aren't restricted so much, so you usually have way more rights than you have in your on-premises data center. You can just walk in and plug and unplug cables in the cloud, but not in your on-premises data center. A good idea of what you can, or where you can help yourself is if you ever needed to configure DNS entries for scan listeners, so multiple IP addresses for the same DNS entry. For example, if you want to set up RAC, Oracle Real Application Cluster, all this kind of stuff, then you can do it by yourself in the cloud without explaining this complicated task to the network staff. Okay, so what are clouds made of nowadays? Well, Linux servers mostly. And besides these Linux servers, there are lots of other supporting stuff inside the cloud, and mainly network components. Luckily for what's happening here, I'm pressing the wrong button, sorry for that. Luckily for us, most of the thing is virtual, at least the stuff we can configure and we are faced with as cloud users. And this is defined, software-defined networking, software-defined whatever. So the SDX means it is virtual and we can configure it via software. Okay, so before we dig into the network stuff, let's have a little look at the basics of the Oracle Cloud infrastructure. I took this picture from a German marketing slide, and there are a couple of German words on it, but I think we will make it over together. So on the foundation of the Oracle Cloud is the Oracle region. An Oracle region, to give you an example, is Frankfurt in Europe, Frankfurt or Amsterdam or Zurich, or the big US region in Ashburn or Toronto or whatever. And those regions consist of data centers. And these data centers are called in Oracle terms availability domains. And they are abbreviated by AD typically. The aim of Oracle is to have at least 3 availability domains in every region, since the Oracle Cloud infrastructure is expanding very fast at this time. They didn't achieve that in every region, as far as I know. In the Swiss Zurich region, there's only 1 data center available, and there are a couple of more which have only 2 data centers. But the aim is to have at least 3 availability domains in every Oracle region. The data centers are equipped with very fast physical network and all this computer stuff, and even they are interconnected. All data centers inside the region are interconnected via a very fast physical network as well. Above this physical network layer, here comes the virtual network, and this is the first layer that we can access. And as you can see at the how the slide is structured, or how the picture is structured, the virtual network is really the basement and the foundation of what we can change and what we can configure. So the virtual network is really important. Building on the virtual network came all the services that the cloud has to offer: compute, storage, database, autonomous database, networking itself, of course, with all its higher networking services, and all this kind of stuff. And building on top of that comes the governance, so your departments, your applications, whatever. And we can, of course, connect on the right side to other Oracle regions, to other cloud providers, or to your on-premises data center. The Oracle Cloud is evolving very fast and is developed very fast by several teams that are distributed all over the world, and that led to a little some kind of confusions, especially in course of terms. There are a lot of terms that are different but meaning the same thing. One important term is identity domain, tenant, and cloud account. Although they sound very different, they mean all the same thing. Whenever someone is talking about an identity domain, a tenant, or a cloud account, it means your cloud space. The name of your cloud space is part of your cloud URLs, and you need to the cloud account together with your password and login into your database. Just to show you an example on how confusing it can be, you see here a screenshot of the login mask that I get presented when I'm trying to log on through the Frankfurt data center directory. It says assign in to your cloud tenant. And if I use a different approach, so a different URL, which leads to the same result, there is a fly around me here, which leads to the same result, I get a different masks that talks about a cloud account, and there says cloud account with identity cloud service. So different terms, same result, same meaning. Just keep that in mind. Another term we have to talk about, because they are very important, are compartments. Compartments are logical dividers inside your cloud account. So you can use them to group cloud resources together. I personally think of them like namespaces or subdomains. You use them to separate your departments or your cloud applications, and the cloud resources used to stay in their compartment. So only recently, a couple of months ago, Oracle introduced a new feature that allowed you to switch some cloud resources between compartments. The month before, you needed to delete and recreate them if you wanted to move a source virtual machine or whatever from one compartment to another. That wasn't a big problem because those are only logical dividers. All resources can always see each other, even if they are in different compartments. Taking the compartments for an example, you can see how fast the Oracle Cloud is evolving and new features are developed. I have an example here. I compiled these 1.5 years ago, and there was a very new feature introduced at October 18th, 2018, that made compartments deletable. And only a year before, they made it renamable. And so if you started with the Oracle Cloud Infrastructure and created a compartment and made a typo before September 7, 2017, you need to live with this typo and with this wrong spelled compartment for virtually your whole life. So you weren't even able to delete it or to rename it. And those features are introduced very fast and very fast pace. And even recently, they introduced a new feature that allows movement of resources from one compartment to the other. Good. Now, let's start talking about virtual cloud network. In Oracle Cloud Infrastructure, you use the virtual cloud network wizard to create cloud networks. And whenever I hear something talking about a wizard, pictures like this little lady come in my mind. And or the other way, an old white man with a hat on it or something like that. But believe me, reality in terms of Oracle computer wizards look very different. So the Oracle Cloud Network Wizard is launched via the burger menu. We will see this in a second. I will give you a short demo of that. And you choose the networking virtual cloud networks, create virtual cloud networks. So very intuitive. You can create resources in one easy step. When you start the VCN wizard, you can choose between if you want to start a virtual cloud network with internet connectivity or with internet connectivity and a side-to-side VPN connect. So there are more steps added to the second wizard. Again, this is a very new wizard. They completely reworked the wizard. A couple of months ago, you had the option between create a virtual network or a virtual network with additional resources. And these additional resources would be created, but you had to accept the predefined IP range. You couldn't even change the IP range. Talking about the IP ranges, all created resources by the wizard can be modified after the creation. With one big exception, this is the IP range. So we have, if you want to change the IP range of our virtual network, we have to recreate the network as a whole. It's not possible to change it at this time. Okay, so time for a demo. Let's have a look at it and let's see if it works. This is my web browser here. I just went to Oracle.com Cloud Sign-In, and my cloud account name, my tenant or my identity is Robbie Databee. I just choose, this is my username and password. So let's go to it. And my primary region is Europe Frankfurt. So I come to console Europe Frankfurt 1, you see in the URL. And this is the startup screen that you get presented after logging in. So we can even, they added a couple of quick actions. So we have the networking wizard right here, but just let's click away this COVID-19 message here. So we can start the wizard from right here, but the way I showed you on the slides is press the burger menu and the upper left buttons. go to networking, go to virtual cloud networks. And so this is the list of my virtual cloud networks that are in my root compartment. I don't have any there. Let's see if I have some in my, these are my subcompartments. So I have a DOAG, German Oracle User Group compartment, the database community and the development community. And let's see what's here. Oh yeah, and this was for my try run. So let's just terminate that here. I did a dry run just before the real presentation, so, and it didn't clean up after all, but this works very well. So here is it gone. Let's see if we have one here as well. Delete it, terminate is the correct term, and throw away. And off we go. So let's start with the database compartment, and let's say, so now the choices are create virtual cloud network. You can configure everything by hand or use the wizard. Let's see what happens if we say we want just create a network. Let's give it a name. Let's stick with the name I chose in the dry run. Lux Oracle User Group 0. Let's take plain. We want to create it in the compartment. Every resource you create has to be placed in a compartment. So we want to choose the compartment DOAG database. The CIDR block is the network block. So let's just type something. Let's say we start with 10 and then 168 and then 10.24/24. We can have a DNS label, which will be LuxOUG plain, and a DNS domain. Here we go. Advanced options are not that much. You can add tags. If you're using the cloud a little bit more intense, you will be happy for every option that to group resources together, because resources tend to multiply, and you will have lots and lots and lots of different resources in your account. And so tag is one way to group them and to do reports over them and find them. But we don't want to add a tag at this time. Just create the VCN. And as you can see, this works very fast, and we have created a VCN. Together with the VCN, we got a route table, we got a security list with our firewall rules, and that's it. Okay, so let's see what happens. We are going to the development department, and the developers are a little more lazy than the database guys, and they want to use the wizard and create more stuff in a single step. And this is the new wizard I talked about. We have the choice between virtual cloud network with internet connectivity or with internet connectivity and VPN configured in one single step. So the VPN part would be too long for the demo, so let's just create an internet connectivity. Here we are. Let's call it LuxOUG and wizard. Wizard, yeah. Wizard. It is in the compartment DOAG-dev. Let's configure the subnets. So again, this is a new feature. A couple of months ago, you couldn't change the IP blocks, but we can change them now. So let's see, we want to go here to 160, and let's take the 70 block, and we have to put the subnets inside the big CIDR block. So this will be 160 and 1, or let's say, and 15. I'm just making up numbers here. And 160 and 25. Yes, we want to have the DNS resolution. Again, we can show tagging options here. Let's go to the next step. We get a summary here, and we together with our virtual network and the two subnets, we get a couple of gateways, an internet gateway, a NAT gateway, and we will see what these are about in a couple of minutes. We get security lists, routing tables, and all this kind of stuff, and say, okay, go ahead and create. And as you can see, this works very fast. And now we have created a virtual network. And we have a virtual network. We have a public subnet, which is reachable from the outside, from the internet. We have a private subnet. And that's all I want to show you for right now. Okay. So let's continue. So by the way, these are my demo backup slides. These are the screenshots from the old wizard. I will update those screenshots before downloading the slides tomorrow. So when you download the slides, you will get the demo screenshots from the actual user interface. Okay, let's talk about the networking stuff. If you want to configure network components in the Oracle Cloud, we have a couple of terms we stumble over. The first is, of course, VCN. VCN is short for Virtual Cloud Network. And in the Oracle Cloud, it is IPv4 only. So we have no IPv6. That isn't much a difference to the other clouds. Most of the other clouds I know are running on IPv4 only as well. It's just for you to know. In the Oracle Cloud, VCN covers a single contiguous CIDR block, so a single contiguous IP range. Other than other clouds, you can have, if you want to have multiple IP ranges, you need to set up a virtual cloud network for every range. That's not a big problem, just a thing you need to know and to consider when planning your networks. Cloud resources cannot be placed into virtual networks directory or your virtual network cards you create, but they have to be placed in subnets. So every VCN needs subnets, and you can choose between a regional scope, so a subnet that works over all data center in a region, or you can assign it to a specific availability domain, so to a specific data center in your region. This is a new feature as well. A couple of months ago, you needed to set up a subnet for every region and do the route. The routing was handled by Oracle by default, but you needed to set up a subnet for every region. So if you want to create a virtual network interface, the VNICs here, they have to be assigned in a subnet, and every VNIC in the same subnet share the same routing table, the same security list, and the same DHCP options. Okay, so I told you that Oracle networking in the Oracle Cloud is IPv4 only. And there are public and private IP addresses. The public IP addresses are unique. And when I say unique, I mean worldwide unique. So you probably heard that those public IP addresses are limited and that we are at the end of the available space for public IPv4 addresses. Nevertheless, the cloud providers, all cloud providers did acquire companies over the couple of last years with the only goal to acquire those IPv4 ranges. And Oracle did so, and all other cloud providers did so as well. And they have lots of IP addresses available. So that's not probably a problem. Nevertheless, there is this problem, the networking guys are aware of the problem that these IP addresses are limited. And so they standardized on private IP addresses. Those private IP addresses are predefined ranges that are used over and over again. And since those addresses are private, packets with an address in a private network won't be routed to the internet because no internet router knows which is the real destination. Okay. So these are the private IP networks. We are not going over the details, just for you to know that there are 3 different blocks. There is a 16-bit block, which has 65,000 addresses, and the range is going from 192 to 168. You probably get assigned one of those addresses from your DSL router at home. Then there is a 20-bit block starting that has over 1 million addresses divided into 16 small networks, and these addresses started with 172. And there is a big 24-bit block with 60 million addresses, and in a single network ranging from 10, the 10 network at least. So all IP addresses starting with 10 are never routed to the internet. And if you remember what I just entered inside inside the wizard when we created the virtual network in my cloud account, this address started with a 10 as well. So just for you to consider, the lower block here is often used in home cases or in small offices. These ones are used mixed, and these are typically used, the address block that are used in big organizations for their virtual network setups, or for their physical network setups as well. So IP addresses in the same subnet are considered local. That means no routing is required. Local means your network card assumes that it can reach the address of the destination from a packet if it's local directly by sending your package directly to the next network card. This is calculated by subnet masking. And subnet masking is a very simple binary AND operation. You can do this by hand by yourself, or if you're lazy as I am, just Google for network calculator or IP subnet calculator. And there are lots of good websites outside where you fill in the information you have and get calculated the missing parts. Nevertheless, let's have a look on how this works. IPv4 addresses are 4 bytes divided by a dot usually. So every one of you should have seen an address like this here. So we have an address 192.168.132.197. And for the network interface card, it looks at the binary representation. Each byte has 8 bits. So the decimal range will be from 0 to 255. So there will be no number greater than 255 in an IPv4 address. And this is the binary representation of this IP address here. The subnet masks, every one of us should have seen something like that. This is 252, 252, 252, 0 in this case. And the binary representation of this mask is lots of ones and a couple of zeros at the end. And if you do a logical AND operation, we get the network address. So so if you do the logical AND operation in this case, we get this address 192 blah blah .0, and every address, every IP address that resides in the same network address. So if you do the binary AND operation with the network mask to the address, every address that has the same network address will be considered as local as in the same subnet. This is how you type this. If you're a Windows user, you probably have typed, or a Linux user as well, you probably have typed in one or other case something like that. My network, this is my network address mask or net mask if you're on Linux, with the net mask with the 255.255.0 at the end. This is a lot of characters to type, so some guys considered of a shorter notation, and this is the CIDR notation. The CIDR notation is just the IP address or a single IP address from the network. Usually you use the lowest one, the network address, but you can use any other, and a slash, and a number. And the number calculates very simply. You just have to count the ones in the network mask. So if you have a look at the binary representation of the network mask here in the third line, in the fourth line of this table here, we will see that there are 3 bytes of all ones. So 3 times 8 is 24. Our CIDR location is /24. And it's that simple. That's is the CIDR address calculated. And one may ask, what happens if there is a 0 before the first, there is a 1 after the first 0. So imagine there is a single 0 here. What would the CIDR number looks like? Well, it's very easy to answer that. This will be an error. This is a not allowed this is a not allowed subnet mask, and your IP stack will throw you an error and not accept that mask. Okay. So let's have a look at a couple of examples here. In that case, let's say, okay, I have an IP address. I intentionally didn't choose the lowest number from the network here, just to show you that it's possible. So we have that IP address here with a network mask of 28. This is the decimal representation of this network mask. And let's just show what happens. So let's take this IP address, the IP address from the network notation, by the way, and apply the mask. And this will be the result. We have a 192 at the end. Let's have a look at the next IP address. If we take the 190 and apply the mask, we will see that we get a different masked IP. So this IP is not in the same subnet, and there has to be routing. There has to occur some routing that you can reach this IP address from that IP address. Next address is the same thing. We use the 209, we will get a different network mask. And if we use the 200 at the end, that will be in the same subnet than the first address, and the first line and the last line will be in the same subnet and can reach without routing each other. Okay, these are a couple of more examples of subnets. I'm not going to read them out. Just if you want to read the table by yourself, I just have entered here the lowest IP address, lowest usable IP address, and the network address. The network address isn't usable as an IP address because it's the address of the network. And the same as with the highest IP address. The highest usable IP address from this network is one lower than the highest address than the highest possible address from this range. And the highest number is called the broadcast address. Every package that is addressed or that has a destination with the broadcast address will be distributed or read by all network cards on the subnet. So if you do a ping on your network, this will usually use the broadcast address, and every not a ping. If you an ARP request, if you do an ARP request, that will use the broadcast address, and you will receive answers from every network card on the on your subnet. So, why is planning ahead is important in terms of IP routing? IP routing occurs whenever a packet has to leave its subnet to reach its destination. So you can easily think about that if you say the network is the destination IP address is not in the same switch, so not directly cabled together. Addresses on the own subnet are considered local. These are the ones where no routing occurs. And this is the reason why you should never overlap IP ranges in networks. You can do this, but then you are in deep trouble to keep these stuff together. You can do this, you can overlap IP ranges, and you can use subnetting and nutting and all this kind of stuff, but you probably don't want to do this if there is a chance to avoid it. So please plan ahead, use only new IP ranges for your networks, make them as small as possible and as big as necessary. Remember, a couple of months ago, you had to have at least a single subnet for every availability domain. So your subnet should be your network range should be big enough to fit 3 times of all possible IP addresses or of the number of machines that you want to reach inside your network. This is not longer necessary, so you can make those IP ranges even smaller, but make them big enough that you have space to move around. Think about as your cloud account as a new data center. So this is a chance for a fresh start. So you can avoid all the mistakes and errors you made when you set up your last data center on premises. Ask the guys who did those mistakes, do proper planning. And there will be a lot of quick and dirty trials. So if you're playing around with your cloud account, just spinning up a couple of virtual machines, setting up a couple of networks like I did with just entering some random IP address ranges, don't let those become productive. It is very easy in the cloud to destroy and to tear down installations and setting them up again. Do this. and do this in a proper way so that you don't get a headache afterwards. Okay, let's continue having a look on those network interface cards, on those network terms or components that are in the Oracle Cloud Infrastructure. One of the most important things is probably the VNIC, the Virtual Network Interface Card. Every virtual machine needs one. There are a lot of more resources that need network interface cards. Every VNIC has at least one private IP address. So one IP address from a private network. The first private IP assigned to a VNIC is the primary IP of this network interface card, and it will be unchanged during lifetime. So you can't change the IP address, the first assigned IP address to a virtual network card. If you want to change it, you have to destroy or to tear down the network interface card and rebuild it. It's not a big deal, but you have to be aware of that. Public IP addresses are routable from the internet. You can optionally assign them to those virtual network interface. A single virtual network interface can have multiple private IP addresses as well if you need that. And public IP addresses are free of charge in the Oracle Cloud. This is a difference to other cloud providers. The 50 static IP addresses are free available for playing with. If you need more, you have to open a service request and you will get probably assigned more free of charge, or you have to talk to your sales representative. If you want to set up a public IP address, you need a public subnet, so a subnet that is declared public, and an internet gateway. And if you remember the wizard I just clicked through in the first demo, we got created a public subnet and an internet gateway for that purpose. We have routing tables inside our network. So you define routes from one subnet to outside the VCN. The default routing table is empty. So there is a routing table there that will be that is created with your network, but it is empty. We have security lists. Security lists are firewall rules. So every cloud has a firewall available up and running, and those firewall rules need to be defined if you want to have traffic between your virtual machine. There are two kinds of firewall rules: stateful and stateless. Stateful means that the firewall keeps track of your IP packets, and if you send out an IP packet to somewhere, and a response comes back from a direct response to this packet comes back, the firewall will let it pass. This means stateful. Stateless means you have to define rules for both ways. The stateless thing was important back in the days when memory in routers were very expensive and tend to get full with or filled up with those stateful rules, and then you needed to define that. Nowadays, you usually go with stateful and you're happy. The rules are named ingress and egress. Ingress means inbound and egress means outbound. The reason why they aren't called inbound and outbound is they not only apply for inbound and outbound traffic, but for traffic inside your network as well. So if you have set up a subnet and have fired up two virtual machines with two different virtual network interface cards, these two machines can't reach each other with packets directly, only for the rules that are allowed. So firewall rules are will affect the traffic inside your subnet as well. This is by the way default for every cloud provider, and this is one of the reasons why clouds are very secure and there are not that much breaches and incidents happens in public clouds, because you really have to allow every network path. And this is a great difference to your on-premises network, where the inter-subnet traffic is allowed by default by your switch. The default set that is generated when you generate that is in place when you generate a new virtual cloud network consists of ingress rules that allows SSH. So SSH traffic is always allowed, and two types of ICMP traffic. ICMP are those ping responses, and the type 3 and 4 are packet fragmented and some error message. We will see this in a second. And the other rule is that any traffic in the outbound direction, the egress direction, is allowed. So the inbound direction, the ingress direction is very limited, and the outbound is allowed by default. There are DHCP options. DHCP is a protocol that allows you to configure IP addresses for virtual network end cards or to assign IP addresses automatically. This DHCP standard has lots and lots of options. There are over 100 of things you can automatically assign to network interface cards, from DNS servers over to time servers to all kinds of stuff. The Oracle Cloud has very limited options to be precise, the DNS type and the search domain. And that's all you can configure for the standard DHCP options. If you want to have more, you have to set up your own DHCP server. Okay, so let's click around. We have a couple of minutes, so let's see. What I wanted to show you are the security lists and the DHCP options. So this is my wizard, my network created by the wizards. Let's have a look at our, and we got created 2 subnets, 2 routing tables, 1 for every subnet, the security list and the DHCP options. Let's just have a look at the security list. And this is the security list for the private subnet. Let's have a look at that. And you can see we have 3 ingress rules, so the inbound rules. This one allows the destination part, the traffic to TCP 22, and 22 is the TCP traffic for SSH remote login. By the way, these comments are generated automatically, and this is very helpful. So if you set up your own rules, you will get, if those are known ports, you will get up those comments generated by default. The next rule is, and this SSH is for our subnet only, and for our virtual cloud network only. This is the range of the cloud network here. And the next are those ICMP package 3 and 4 for the world 000 here. And here is ICMP 4 destination unreachable, fragmentation and needed, and don't fragment was sent. Those the one is 3 and the other is 4. And 3 is destination unreachable. And this one is the third rule defined only for our subnet. If we have a look at the egress rule, there's only one, and that allows all destination, all protocols, and so the egress way, the outbound way is allowed by default. Okay, that's it for those options. We wanted to look at the DHCP options. Just go there. DHCP options here. These are generated here, and if we have a look at those, we can just click on those 3 dots here and say edit. You can see, okay, we have default DHCP options, and we can say, okay, we want our DNS type as internet and VCN resolver or a custom resolver and the search domain. And this was generated by the wizard. Okay, so back to the slides. We still have a couple of minutes. So those are the demos. And again, before I make the slides available, I will update those to the latest version, to the screenshots. And let's have a look at the gateways. The gateways that are generated, there are several types of gateways. And because it's easy to define different gateways for different purposes, Oracle did so. So the only thing you need to know is that depending on the task you want to achieve, you want to set up a gateway as a router, a virtual router. Depending on the task, you need to choose the right router, and then everything will work out fine at the end. So if you want to do dynamic routing, this is meant for VCN and on-premises connections or private network traffic connections, use a dynamic routing gateway. If you want to go to the internet, use an internet gateway, and so on and so on. Those are the 2 peering options here. and the service gateway is used for other services in the Oracle Cloud that are outside your virtual cloud network, for example, object storage or your backup stuff and all this kind. Okay, how do we get to the cloud? We have different paths into the cloud. One is the SSH tunnel. This is the thing we always get set up in the demos that are provided by, say, be it Oracle, be it Azure, be it Amazon. And so you just SSH to a public IP address of your virtual machine and open and do port forwarding so that the ports from the traffic to the ports on your local machine are just tunneled to the cloud. This works well, but only for testing and development. You don't want to have SSH tunnel for production setup. The next thing is a custom firewall appliance. And this is the method of choice in the Azure cloud and the, as far as I know, in the Amazon cloud as well. So you just spin up your own compute instance, your virtual machine, provided with a custom image where your firewall appliance is there, and do your setup as you wish. And if you assign it a public IP address, you can do your can set up your VPNs as you need it and as you want to have them. The preferred way by Oracle or is IPsec VPN. You do that by a dynamic routing gateway, and this will set up an IPsec networking between your on-premises or and your on-premises network and the cloud network, or between two cloud networks. And the final option is the OCI Fast Connect. Fast Connect means you have your own private connection. You have a real or virtual private line, a cable that gets plugged into a switch that is inside the data center. This peering can be private or public as you wish, and it sounds expensive, and it is expensive, but not in terms of the cost of the cloud, more in terms of costs for the leased line that you have to have, because you need the leased line from your data center to the cloud data center, and you need a dedicated leased line inside the data center to the so-called meet me room where you plug in those cables. Okay, so this is how IP tunnels work. You just open a port on your local host, do an SSH connection to a jump server over here, and forward those packages to your destination host. This is very straightforward. I took this screenshot from MobaXterm. This is my preferred terminal environment for Windows. This illustrates how this works. If you want to connect to an Automomous database in the cloud, we have a little problem because those can't have virtual network interfaces. So the access is encrypted via internet. What you need to do is you download a wallet. This is a zip archive containing a couple of certificates. And you, if you want to use SQL Developer, you can just import it directly to SQL Developer, or you have to unzip and configure it for SQLnet. And then you can connect to your Automomous database. Let's talk a little bit about costs. I prepared this slide for a couple of currencies. The dollar currency is the most stable because there is no currency conversion in. So let's have a look at the dollar slides here. So this is, I took this screenshot here on the left side from the Cloud Oracle.com networking pricing website. And I did the screenshot from today. The good news is I had another screenshots from 2 years ago or 2.5 years ago, and the prices were the same. So the prices didn't change. And if you see the first 10 terabytes per month are free, and the inbound data is totally free, and the outbound data from perspective of the cloud is built after the first 10 terabytes. And sorry, let's go back. And the gigabyte price is less than a cent per gigabyte. And this is close to the Oracle won't make any money about out of networking, because those costs are very close to the charges Oracle is getting charged for the big internet connection nodes like D6, DE6 here in Germany, or ME East and ME West in the US. So the maximum cost, if you have a 1 gigabit connection to your cloud, and you have it up 1 month and fully loaded over 1 month. Let's just calculate that. Let's think we have 30 days in a month, 24 hours. So this and it will roughly take 3 hours for a terabyte. I know you can, if you really use the full gigabit line, you can make it in 2 hours and 40 minutes, something like that. But just for easy calculation sake, let's say we need 3 hours per terabyte. So that means we can transfer 240 terabyte per month if we use our gigabit line to the full. And the first 10 terabytes are free, so let's remove that. So we have 330,000 gigabytes that we have to pay for, calculated by the price, and we will get less than $2,000 per month. And this is the maximum price you have to pay per month for the network, and that means you need to set up a really big cloud infrastructure environment with lots and lots of servers that are all sending out data to the internet, and this really rarely happens. So you can keep in mind the networking is the cheapest part in the Oracle Cloud. Let's have a look at the Fast Connect cloud pricing. Fast Connect is astonishingly cheap. So if you want your own 1 gigabit per second line, you only have to pay 21 cents per hour, which is a little bit funny because usually you don't send a technician once a day in to plug in your cable. So typically you have to pay this for the whole month. So again, let's calculate that here. We have 24 hours per day, 31 days. So we have 744 hours in a month. And the price for the 1 gigabit per second lane will be $158. If you want to have 10 gigabits, you only have to pay $900. So this sounds very cheap, but you have to keep in mind that you have additional costs. So you need a network provider. So you have to have a leased line, a dedicated line to your, from your data center to the cloud data center. This is probably the biggest part of the cost. And inside the data center, you have to lease a line as well. I put that in bracket because I don't know what is true. Some Oracle officials told me that you don't have to pay any OCI outbound traffic if you're using fast connecting, and this is what's stated here. On the other hand, if you have a look at the cost calculator, the cost estimator, and I did that today, it calculates the cost of the gigabytes as well. So I'm not sure what really happens, what Oracle is really charging us, since I don't have a leased line or fast connect available. So there are two options. One is you don't have to pay those $2,000 here. The other is you have to pay it. I don't know. On the other hand, the good thing is I didn't make much of a miscalculation here. So even the cost calculator says that the 1 gigabit line cost us $158. I don't know where the difference came from of the $1.10 to my calculation, and $949 for the 10 gigabit line. Good. Final topic before we come to the end. Scripting. Scripting means automation, and this is the bare definition of infrastructure as a code. So building up and tearing down virtual environments happens very frequently in the cloud. So you will find yourself, if you start working with the cloud environment, you will find yourself rebuilding virtual machines and stuff over and over again. And this is mainly because some changes can be only made by recreating the resource, for example, changing the IP range of a virtual network. And the provisioning the cloud resources by clicking in the user interface is very tedious and error prone. You will find yourself abbreviating and leaving out comments at latest at the third time you recreate the same resource. and you are doing typos and all this kind of stuff. So my advice is use the web interface for orientation only, just to see what is possible, what you can do, and what the correct terms are used for the things you want to do. And then script everything. Scripting is automation and documentation at the same time. So if you script your setup of your network or your virtual environment with virtual machines, you have it automated and you have documented at the same time. And this is really the bare definition of software-defined infrastructure. So the scripting options we have is the REST API. This is the master. It provides you access to all resources and options inside the cloud. What is not available via the REST API isn't there as a feature. On the other hand, scripting is using the REST API is more programming than scripting because you need to do all this kind of state checking and error checking and all this kind of stuff. There is an OCI CLI. This is the command line interface to the cloud, and I have an own talk about that. And that is Python based. It's available for Unix and Windows and for macOS as well. It is open source, hosted on GitHub, installs very easy. The installer will even install Python if you don't have it on your Windows machine. And it is also, it is open source. It is developed by Oracle and maintained by Oracle. So it will cover all the features. The de facto standard of scripting the cloud is HashiCorp Terraform. HashiCorp claims to have scripting across all major infrastructure as a service providers. So the idea is that you have to write a script only once, and you can fire it against multiple providers. This only works, of course, if you don't use any specific features that are available only for a specific cloud provider. The provider for Oracle is open source as well and developed by Oracle. So Oracle makes sure that all the features are there. And finally, you can choose your configuration management tool of choice. I picked as an example Ansible, but there are Chef and Puppet and all these other kinds of tools as well. And again, there are OCI modules provided by Oracle here. Okay, so finally, networking in the cloud is basically the same as networking on premises. So your cloud account is like a new data center. Use your chance, plan ahead. And the web interface is only the second best thing. Script everything. Please do so. And if you do so, not the sky, but the cloud is the limit. This little line should be over the sky here. And please, please, please do try this at home. Networking is cost-free in the cloud, so go ahead, use it at home. And thank you for your attention. I'm done. Any questions?
Thank you, Robert. We have one question here.
Okay.
How do you get to the network utilization report?
A network utilization report? Actually, I don't know.
Maybe on financial.
I never had the requirement, but we can have a look at the cloud interface if we find something like that. I would have a look at again in the burger menu. At the bottom, there is account management, and you can go to the cost and usage report. I would search it here. And since I don't have much going on in my cloud account here, since it's full payment account with any free option, without any free options, I would find it here. I think, or we will find it. I have no idea. To be honest, we have to ask Oracle how to do that. I have no idea.
Okay, maybe set up some alert or something like that.
Yeah, probably.
Okay. Thank you so much for your wonderful presentation.
It was a pleasure.
Yeah. So we need to move to the next lecture. It's about time right now. Thank you so much. And thank you for all attendees to join us today. So now we will have the presentation from Alex Zabala.